this unit. So it's a bit of a break after that last one. A bit of a break. Okay, so we're starting sequences and series. There's only 5 lessons in this unit, so it won't take too terribly long. It's a pretty simple lesson. Today is probably the most confusing day out of it all because there's a funny symbol I gotta show you about. And I debated just skipping it because I couldn't recall ever seeing it on any test. But I asked the other math teachers and they said, yes, it's on the ACT. So we're not gonna skip it, we'll give you that chance if you see that on the ACT. Alright, so sequences and series, that's just patterns and type stuff. Now it does get more specific, there are some formulas that we'll learn, but starting off with something like this, that does read, that A base N is what that reads. Okay, so what we've got here is the equation for a pattern. And it's wanting us to show what the numbers of that pattern would be. So the N always stands for the number of terms. Okay, so if this wants the first 6 terms, we're going to have, oops, let me pick a marker. We're going to have term number 1, comma, term number 2, comma, term number 3, comma, term number 4, comma, term number 5, comma, term number 6. And those are the N's that you plug in. Okay? So for term number 1, you would say, put a 1 there. 2 times 1 is 2, plus 5 is 7. So our first term in this sequence would be, where's my marker at? Would be 7. That's it. Okay, but I asked for the first 6, so for term number 2, we would put a 2 in for the N. 2 times 2 is 4. 4 plus 5 is 9. Pretty difficult, right? Okay, for the third term, you plug a 3 in. 2 times 3 is 6. 6 plus 5 is 11. Now from here, you could keep using the formula, or you can probably just fill in the blanks, can't you? What would term number 4 be?
13.
And then? And then?
17.
Okay, so let's see if we put a 6 in, if that's true. 2 times 6 is 12. 12 plus 5 is 17. So, very good. So what we're going to see here in a minute, let me erase those term numbers down there because I don't want that to confuse you. What we're going to see here in a little bit is we'll go backwards. I'll give you those numbers and then we have to be able to write the equation. Okay, you paying attention? I'll give you those numbers and then we have to be able to write the equation. So thing that you would notice is that it is going up by 2 every time. Do you see that accounted for in that equation anywhere? Mm-hmm. And then it didn't start at 1 or 0. So if it's going up by 2 every time, what would we have to, if I gave you 7, what would you have to do to that 2 to get the 7? Add the 5. Okay, so that might be a hint for us in a minute when we have to do that. That's some words I don't know about. Those grammar and English things. Whew.
Wait, what does base mean again?
What's base? What are you talking about?
Like a base mean?
Any number. So that could represent any number.
Oh.
So that
I
would.
just forget what base does.
Well, no. This is not log or anything. This is just a symbol. It's like a new variable. So don't try to make it do anything. It's just a new variable. It's not working. There we go. Okay, so let's write it a different way this time. Let's say f of n, I used function notation, is equal to -3 to the n minus 1. And I want the first 6 numbers in that sequence. So how am I going to get the first number?
1.
Okay, I plug a 1 in for the n. So that means I've got -3 to the 1 minus 1 power, which means I have -3 to the 0 power, and anything to the 0 power is 1. There's our first term. We got to find 5 more. So I'm going to plug what in for the n to find the second term.
2.
So -3 to the 2 minus 1, which is negative 3 to the 1, which is negative 3. Okay, what am I gonna plug in to find the third term?
3.
Man, this is tough.
I don't know how to do it.
3 minus 1 gets me,
That's
Two.
gonna be me in the test. I don't know how to do it.
what's negative 3 to the second power?
9.
9, very good. So we got 3, now I need to find the fourth one. What am I gonna plug in to find the fourth one?
4.
Ooh. So I'm looking for negative 3 to the third. What's negative 3 to the third power?
27.
Close.
Negative 20.
Negative 27. Okay, I got 2 more to go. Negative 3 to the fifth power, what am I gonna plug in for M?
5.
Minus 1 would be negative 3 to the fourth, which would be what?
Negative 36.
Nope.
No, negative. Negative 81.
Close.
80.
Be a positive 81.
That's,
Remember, if you do a negative in your calculator, you gotta put it in parentheses.
Oh, yeah.
But when it's an even number with a negative, an even exponent with a negative, will always be positive. Alright, so 2 more, no, 1 more, that was the fifth one, right? 1 more. Negative 3 to the 6 minus 1, which is negative 3 to the fifth. What does that get us?
Negative 2.
Negative 243. So there would be our, now you could look at that, and you know, you could see a pattern there. 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, so you see that that's being multiplied by 3 every time.
Negative.
And then because it's a negative, that's where I was going, very good, Christian, because it's a negative, it flips signs, which means you would ultimately be multiplying by that negative. Because a negative times a negative makes positive, times a negative makes a negative, times a negative makes positive, so it flip-flops it back and forth. Very good. He saw that one happen. He saw it.
I saw it.
Is that some kind of dinosaur? I saw a Rex. Dinosaur.
Okay, so here we go. We got, I think I wrote something wrong. Negative, yeah, I missed a negative on that 8. Negative 1, negative 8, negative 27, and negative 64. And we gotta write the rule. So anytime it says write the rule, that just means write the equation. So we gotta find out what's going on. What is the pattern that's happening?
I wanna go from negative 8 to negative 27.
Mm-hmm. What will be?
Wait,
Negative
times
times
9.
What's 9?
What?
Something to do with 9. I think.
Okay, on the problems that we worked previously where I gave you the equation, that equation was always based on the number of the term. So our first term is negative 1. Our second term is negative 8. So what could we do to 1 that gets us a negative 1? What could we do to 2 that gets us a negative 8? What could we do to 3 that gets us a negative 27? What could we do to 4 that gets us a negative 64?
square.
Okay, it's gonna have to be a power probably. So let's try, my first term is first term squared. Oh, but that doesn't equal negative 1. So, what else could I try?
Like, would I make it a negative?
We're not, no I involved here. All of these are negatives.
Put it to a negative.
Okay, hold on a second, and we'll talk about that. All of these are negatives, so it can't be a square, because when you square something, it becomes positive. So what's another power other than squared we might try?
Negative 2.
a negative
No,
power would make it a
fraction.
fraction, we don't have any fractions, what'd you say, Christian?
We would do this fraction.
We don't have any fractions.
Not like a fraction would have it.
Well, why do we wanna already start trying fractions when we haven't even tried easy whole numbers yet?
Would you cube it?
Okay, let's see, if I cube my first term, that gets me a 1. I need a -1. If I cube my second term, that gets me an 8. I need a -8. So I'm on to something. If I cube my third term, that gets me a 27, but I need a -27. So what possibly could I add to what I'm doing here? Instead of just saying n cubed, what could I do to that?
You could say negative n, because that's the same thing.
What's the same thing? Would that not work?
Could you do n cubed and then parentheses negative?
No, cause that would make it a 1/3. Look at what I just wrote, would that not work? First term, make it a negative, cube it. Second term, make it a negative, cube it. Third term, make it a negative, cube it. So, winner, winner, chicken dinner. Now, did you notice what the struggle in that is? Why was that hard for you,
Because it's one of those.
other than that? It was just trial and
Kinda like
error.
trying and error.
And so you have to be willing to try something. And sometimes some of y'all are reluctant at that. You're gonna make a mistake. Y'all see me do it all the time. You just gotta get over it and keep trying, right? Alrighty.
Was that the confusing bit?
No.
Oh.
Cool.
Well.
Let's try one more of those before we look at the last part.
That sounds like a good idea.
Alright, we got 0, 2, 6, and 12, and it asks us to write a rule for that. So we want it to be in terms of n, our number of term. So we're gonna, f of n is gonna equal something. Okay, so our first term is a 0. So term number 1, you wanna, term number 1 is 0. Term number 2 is 2, so that one, I'm just writing things and trying things. Term number 3 is 6. Okay, you notice anything? How can we try something here and start something? I mean, I think I see a 2, 4, 6, right? So I know my next one would be 12 plus 8 would be 20. 2, 4, 6, 8, huh? Y'all follow that? But we gotta be able to write that in an equation form in terms of n. Okay, so f of n, it just can't be the term number.
Minus itself.
Okay, so you're real close on that. What if I took the term number, which my first term is 0. So 1 minus 1, right? That would get me 0. Does that work on this second one? 2 minus 1, no.
Could do n minus n, and then something after that.
And my sim will always be 0.
I didn't know if there was a way of like making where we could add it and then like consecutively go up 3, 4, 6, 8.
No, you're thinking, and I like it. I'm not mad at you. I thought we were about to get there, and then you threw us off the track. Let's go back. Let's get back on the track real fast. My first term is 0, so first term, 1 minus 1 gets me 0. My second term is 2. 2 minus 1 is 1. So I need that 1 that I get from 2 minus 1. What could I do to that gets me a 2? Because it needs to be a 2 right here, right? So I've got a 1 right here. What can I do to 1 that turns me to a 2?
Add 1 to it.
Okay, so does that, 2 minus 1 is 1, 1 plus 1 is 2. Does that work on the first one now? 1 minus 1 is 0, plus 1 is 1. So it doesn't work there. So probably not, we want that one to stay 0. We don't want to add anything to it. 0 times anything stays 0. So instead of adding something here, let's think about what we could multiply by.
Times 2.
Okay, times 2. Now what is 2 in terms of this sequence? This is the first term, this is the second term. So maybe if we multiply it by the number of term, let's try that with 6, because that's my third term. So 3 minus 1 is 2, and then 2 times 3 is 6. 12 minus 1 is 12, dumb butt, it's 4, that's the fourth term. I about messed y'all up. 12 is the fourth term. 4 minus 1 is 3. 3 times 4 is 12. Winner, winner, chicken dinner. Now let me give you a little bit of relief thinking on this, because I know y'all get stressed out when you have to do trial and error. Remember, our tests are usually multiple choice.
Oh, yes.
So that will help you out, because you'll be able to just try the choices, right? Okay. So, the last thing that I was gonna skip, but I'm not going to, is we have to talk about summation notation. That's a bunch of Asian ocean words. Oh, it's got 2 M's.
Something like addition to sum.
Yep. Summation notation. Alright, who knows what the Greek letter epsilon? Not sure if that's how you say it or not. It's the Greek letter E. Anybody ever seen that on an ACT test or anything? You have? So here you go. We're learning about it today. Very good.
Seen something like it.
Alright, so summation notation that says when the terms of a sequence are added together. So that's what we would have here. So if I had just an easy one, 2, 4, 6, 8. 2 plus 4 is 6, plus 6 is 12, plus 8 is 20. So that would have a sum of 20. So we can use this symbol here, summation notation. So what's always going to go on the top is the number of terms you have. So I'm going to number of terms, and we'll fill in our stuff in a minute, but I want you to have this in your notes. Okay, what's always going to go underneath is what term you're starting with, and it's I for initial. So starting term, I starting term. I know that sounds weird, because usually you start with the first term, but you could see something, and I'll erase this in just a second. You could see something that tells you it keeps going forever backwards. Okay, that's not very often though, so let me erase that. Okay, always out here on the side is, where is that? Starting term, yeah. Can't believe you can't read that, jeez.
And starting term is I.
Yes. Well, I was trying to look for a generic term to, sigma is what that Greek letter is called. I just saw that in my book. I thought it had an E in it. Index of summation, that's our I. Lower limit,
Sigma.
upper
No,
limit. Oh, okay. So if our our starting term down here is I, what would we have to do to that to get our first term?
multiply by 2.
So we would have, oops, I need a marker. We would have, I messed up my E. We would have a 2i out here. So for this particular pattern that we have, to fill in the stuff we know, 1, 2, 3, 4 terms on top. Our starting term down here underneath is our first one. And then you would put a 2i out here. And that's it. Now I know that doesn't tell you how to work with it, which is what I'm fixing to do, is show you how to work with one, because you already can do that real fast in your head, 2 plus 4 plus 6 plus 8. So I wanna do one a little bit tougher to show you how to work with it. So, let's say I gave you this. And I told you to write the series using summation notation. So summation notation means we gotta have a big O sigma there. Okay, so what is our first term in this? 25, so our i's 1, so here I would have a 25i, okay? How many terms do we have? Cause I left a space there for you.
5.
Awesome. 7. We were trying to get 7 anyway. Only
Or is it 6 because of that minus 0?
Okay, I don't really know what y'all are talking about right now. I wanna know how many terms are there from 25 to 250 if this pattern continues?
Well, that's 250. Okay. It looks like a 25 minus 0.
Oh, let me fix that, I'm sorry, cause I was really confused about what y'all were talking about.
Yeah, okay, so it's
And so you know 100's next, you know 125's next, keep them going, see how many terms we got.
10.
10. Okay, so what we'll see happen now is we're gonna be given this. This is your summation notation, way to go, you got an A. So now you're gonna be given this, and you gotta figure out what the sum actually is. So here's, this one I wanted to do frontwards and backwards, so, cause this is an easy one to work with. So you would have to look at this and know that your starting term is 25. And this also tells you that you're adding 25 every time, doesn't it? So I wanna add 25 every time, and how many numbers am I gonna have?
10.
Very good. And then you just gotta figure out what that is. 75 and 75 is 150, 250, 375, 475, 525, 525, and 175 is 0, 700, 900, 1150. Y'all check that out and see if that's right, and I just did that in my head. I wasn't even close. 1375 would be the sum of all those. So much for mental math on Monday. Alright, one more problem. I know I said that was the last one, but one more. So you can see when this is a little bit more useful, because that, not really all that much. Alright, so we got oops, hold on, I messed that up. 3 plus k squared. Okay, so we're given this and we're told to find the sum. So what are we gonna do? That's an 8 on the very top, in case you can't tell. What are we gonna do? What's the first number I'm gonna plug in for k?
4.
4, right? Down here tells me where to start. So I'm gonna do 3 plus 4, squared.
49.
Well, just hold on. And then I'm gonna do what next?
10 plus 5.
Uh-huh. And then what?
3 plus 6.
And how far do I have to go?
8. 8 of those.
8 of those are to the number 8.
8 of
8 of those are to the number 8.
Two.
those. I thought it was a trick question.
Alright, so now, that,
So what if it says like K equals 8 and it's only one have to do?
easy work. Alright, so let me get a new color here. So I've got 7 squared, 8 squared, 9 squared, 10 squared, 11 squared. So that in red there's what I'm adding up. I don't wanna try mental math again since I failed.
Is that 108 and?
No, 100, 10 squared, 100. Cause this ended up being 7 squared, 8 squared, 9 squared, 10 squared, 11 squared.
For 15.
115, you were close there, Christian. 115. Okay, so weird, yeah, but like I told you before we started, that first lesson out of this is probably the strangest that we'll see, because tomorrow we're gonna focus only on arithmetic sequences in series. Is that wrong, Holly? Huh?
Wait.
L shape with the first one.
You're adding those and you get 115?
415.
Oh.
Oh, 415.
Yeah.
An L, he said an L.
I put
I got you.
115 as well.
4.6.
Okay, so anyway, tomorrow we're gonna zone in specifically only on arithmetic sequences in series, which means an arithmetic sequence or series means it's being added by the same thing every time. Some of those we started off with today, had a power on them, so that was kind of wacko. But it'll be just addition and subtraction, and then once we get that one knocked out, you go to geometric sequences in series, which is where it's multiplied by the same thing every time. So it gets easier than this weirdness today. Okay, that was the weirdie there. Alright?
I was the middle child of it. I'm not a middle child, so I can say
Well, I am, so there you go.
I don't know how to